Hello everyone, welcome to Murat Karakaya Akademi YouTube channel. In this tutorial we are gonna continue with our serial about Retrieval Augmented Generation, shortly RAG. If you remember that we have already started our Retrieval Augmented Generation tutorial series, and so far we learned how to get connected to Google Gemini as a large language model through its API, and then we already used in depth its APIs specific to Gemini Flash 1.5, so that we can use in the future upcoming tutorial series as the important part of the RAG system. Today we are gonna continue with the ChromaDB. You might know that ChromaDB is an example of vector databases. So in this tutorial we are gonna talk about how can we use ChromaDB to store the vectors and how to execute the similarity search in that Chroma database. And in that context we are gonna see first of all how can we build the knowledge base. In most of the tutorials we can learn that how to import one single document, but in this tutorial we are gonna see multiple document update and how we can vectorize the multiple documents at once, and how can we store multiple documents as a collection in the ChromaDB, and then how can we generate the metadata for these multiple documents. Of course we are gonna apply several things after just saving the documents into the vector database ChromaDB. For example, we are gonna first apply the basic query, and then we are gonna improve the result set as introducing the filtering according to the metadata, and we would like to sometimes remove some unrelated or less related parts from the documents, and I would like to show this how can you do. And in the upcoming tutorial I would like to show how can you create and run a persistent Chroma database, so that you don't need to run each time the document to convert the document as a vector and store the ChromaDB. And in real life we would like to use the persistent ChromaDB. Thus in the next tutorial I would like to continue with that, but in this tutorial actually we are gonna interest in the details of the ChromaDB, and next part we are gonna talk about the persistent ChromaDB. After that we are gonna combine the Gemini and the ChromaDB to create our simple RAG system. However, afterwards I am going to continue this series by adding advanced techniques to improve this simple RAG. Alright, so if you like to learn RAG system in details, please tune into the channel and do not miss the upcoming tutorials. By the way, I would like to kindly request you, please support the channel if you like by clicking the like button and by clicking and providing some feedback like questions or the comments in the comments section. As you know that it is just a live broadcasting, so if you like please share your comments, or now I think you can hear me, right? Share your comments and please your questions. Do not hesitate to share your comments and the questions. I think you can hear me right now. sometimes it happens in the live broadcasting. I lost my connection to the microphone. It happens. So if you hear me, let me know. Okay. If you have any problems, please write it as well, so I can fix it. Alright. Let's continue. Alright. So in YouTube, you can access this Colab notebook in the video descriptions, and the playlist, of course, in the video description. So as I covered in the first part, how does RAG work, I will not go into details, but let me explain something. To run a RAG system, first you need to build the knowledge base, then you need to populate the vector database. In this tutorial, we will do both of them. So during this tutorial, at the end of this tutorial, we will be able to build the knowledge base, and then we will populate the database for speedy retrieval, and I will show you how to improve the results as well. So for the next time, we are gonna just create the large language powered response generation. Okay. So here I will begin with a single PDF document, and I will explain the concepts and the code step by step, so that we can convert the PDF text to a text format in pages. Then we are gonna convert these text in pages to a fixed number of characters. After that, we are gonna tokenize the text, so that in the end we will have some fixed token number text by using the sentence transformer library. After that, we are gonna just insert these vector embeddings into the Chroma database instance. We will create a collection for that. After that, we will apply several queries and monitor the outputs, observe the outputs. After that, to remedy some problems in the vector database results, we will apply filtering methods, and we will apply some other methods to remove less related results from the result set. Okay. So let's begin by building the knowledge base. Actually, when I mean the knowledge base, when I say the knowledge base, I mean that you have some documents, right, in your directories, and you would like to ask some questions to some documents located in that directory. These documents could be in any format actually, but throughout this tutorial, I choose to follow on with PDF documents, but you can easily download other the opener files like the for docx and the other files, and you can convert the knowledge stored in that documents to text file, and then you can follow all the steps that I will show you. But to keep the things simple, here I will show you how to convert, or how can you deal with the PDF documents for that. First of all, we need to upload these PDF documents from our local computer to the, as you see on the left side, to the Colab environment. So basically, I will use this simple function provided by the Google Colab actually. You can just run it, and it will provide this simple interface, so that you can just click and upload as many as files you like. So let me show you how can you do. So click the choose files, and it will open a simple interface. In that interface, you just click the files you like to upload. Okay, and you don't see my screen for the moment, but it's very simple. Just click the files that you like to upload. Okay, and then click open. Okay, for this moment I will choose a single file, and I will show you how to do with the more than one file in a moment, but I will explain the concepts first, Then I will go to the some explanation for the multiple files later. After that, on the left side, you would see that, let me refresh, the file is uploaded here, right? And the explanation here. You can get the name of the file basically in the file names list. And here you see that you have to just end up with the name of the file. Okay, it's not a big deal, but it's a start to create your knowledge base. Now, the first thing first, we need to just convert the given PDF file to the pages. So here is the simple PDF reader. So you can just import this PDF reader from the PDF library or module, and then you can write this simple code here. Just convert the PDF into the PDF pages. If you run this, let me run again. So if you run this function, actually all the pages from that PDF will be converted as text. All right, and let me show the first page here. Let's go down here. That's the first page, beginning and continue. But as you see that there are several errors provided by that PDF. Actually, this is because of the there are some problems with the PDF format and the PDF reader, but it does not hurt us the result. I mean, because you will see that this is the first page is correctly uploaded. Okay. Let me continue and create another helpful function to just output the file in a better format or the text, because we would like to read the text not for the large language model but for a human being. So my function to markdown, as you would understand from the name, it converts the PDF text to a markdown format. Thus, if there is some listing, we will see the listings better. If there is a bold font, we would see the bold font better. That's the whole reason. To markdown is just a simple function to print the text better. All right. So if you see that here, we would see there are 8 pages from that PDF document already converted to text. However, we cannot handle the pages or the text in pages. We need to convert them to some chunks. So chunk means that partial document. And how can we do? There are many different ways, but the simple way is to first convert these pages into fixed character size chunks. So here I will just convert each page 1500 character chunks. Chunks means that partial documents. And how can we do? Actually, there are lots of libraries for that, but one of these and frequently used one is recursive character text splitter. As you would understand the name, you would provide some rules. According to these rules, it recursively tries to split the character. First, it tries to split the characters in paragraphs. After that, for the statements. After that, for any spaces. So we would not like to split the some word in the middle. So it is the space here you see. But it tries to create 1500 character long text. So basically, to do so, we have the long chain. I think that you might heard this. Okay, in the long chain we have this recursive character splitter. Okay, and then by using this recursive character splitter, and provide how to split the text into characters. So we basically say that please try to split these text when the paragraph finish. If it is not possible, when the statement finish. If it is not possible, when there is the word is finished. Okay. and we write this, and then we can just use the function to convert this PDF text into 1500 character chunks, as you see that. And then here is 14, as you see that, 14 chunks. So we begin with let me show you here. We begin with 8 pages. Now we have 14 chunks. Each chunk almost have 1500 characters. But if you look at here, that almost 1500, but the last chunk of course could be different number. After converting the text into 1500 character long chunks, now there is another step. This step is very important because in the ChromaDB we will store the vectors for representing the given text. This text not only a statement, this text could be some token wise calculated text. So what I am trying to say, to tokenize a text, to convert a given text to the vector, a vector is a number, collection of numbers. For example, when you say that a vector size 128, basically you are saying that you are gonna represent whatever given with 128 real numbers. That's all. So it's called vector. Also it's called embedding. Embedding means that you provide a text, you convert it into a multi-dimensional vector. That's all. So in the large language models, we use the embedding layer at the most of the time after the tokenization, and we need the tokenized text because the vector, the large language models embedding layers receive the fixed number of tokens, and they can they were already trained to convert this prefixed number of tokens to some dimensions in the vector space. Therefore, we need to be careful about how we are gonna give this text into a text embedding model or sentence level embedding model, whatever this. So in here, actually, I will use the sentence transformer library. This library, sentence transformers library, has lots of different large language models embedding layers. So you can use these embedding layers to convert the text to some high dimensional vectors. But each large language model's embedding layer expects a fixed number of tokens. So how can we provide fixed number of tokens? Because so far we only convert the text into 1500 characters. So that's the main problem. So we need to split these 1500 characters into a fixed number of tokens. So a token you can think that a token is some elements less than a word. So it could be calculated, it could be separated, splitted the word by the large language model embedding layer. So we train this layer so they learn how to split a word into the tokens. But you can think that tokens are a little small parts of the words. However, before providing this fixed token size text, we need to use another large language model embedding layer so that it can split the given text into this fixed number of tokens. Therefore, I will use here distally use base multilingual case version 1 large language models embedding layer. Why I choose this? Because as you understand, it's a multilingual, so I can use in Turkish and English, in French for that. That's the main reason. So here you see that the tokens per chunk 128. Why? Because this model was pre-trained by that size of tokens. So I need to request this so that when I provide the text in characters, I would like to get some 128 tokens size characters back, so that these characters or these text could be inputted to the embedding layer later. Alright, so after explaining all this, let's first get the sentence transformers and use this from this library, distilled-based multilingual case version 1 model, and here I just write another function, convert chunks in character to token. So what we are gonna do here, basically we would like to just convert the text in characters to text in prefix number of tokens. So we provide the text in character 1500, sentence transformer I already choose up, chunk overlap 0, token per chunk 128, because my embedding layer, I will show you in a moment, expects or 128 tokens, prefix number of tokens. Alright, so this function will return me each text split into 128 tokens according to this distilled-based multilingual case version 1. Let me show you some examples so you would understand better. Let me move on. Okay, now look, if you check this, this is the first chunk from which is split into 1500 character long. So this is the 1500 character long text. So it's the chunk 0 actually. Alright, so let me go down. Alright, now you remember that we read the PDF as 8 pages, then we converted 14 chunks. Each chunk has almost 1500 characters. Remember that now by using the above function, I split these 41 chunks. Each of them is 128 tokens. Let me show you here. Now that's the 1500 character long text, and each of them here, what you see, 128 token long text. So these texts are ready to be submitted to a large language models which accepts 128 tokens to convert this text into a high dimensional dense vector representation. Therefore, I will use another, actually the same sentence transformer to convert these texts or chunks into some vector representation. Let me show you this step by step so you would understand. Otherwise it could be confusing. So let me show you. Okay. First of all, in the ChromaDB utils module, we have the embedding function. That embedding function gets a model name to embed, and this embedding function model will be the same model that I split the text into 128 tokens. So I will use the same embedding layer for two things: split the text into 128 tokens and then get these each 128 token text and convert to a vector. Okay, so that's gonna be my embedding function. Look at here. Now the embedding function will receive my chunks which are split into 128 token size, and it will return me the embedding vector. So here let me show this step by step. This is my one of text chunk which is already split into according to the 128 token size, and then output is 1, because I just created only for you an example, one embedding for one text chunk. So it is the dimension is 512, and the first 5 values in that dimension space, you see that it is just real numbers. So actually there are 512 real numbers to represent this text, and this is called text embedding or sentence embedding. Okay, whatever. So basically, after creating all this, now I am ready to create the ChromaDB instance. So therefore I have to decide 2 things. First, the name of the collection. So the collection means that you are gonna upload your knowledge base according to around a subject. So here my subject is papers. I will upload my published papers, 4 of them, into the papers collection. Maybe you have others, not the papers, but you have other collections. So you provide the name of this collection because you can query each collection separately. That's the logical separation. You think the collection as the schema of the relational database. Okay. Another thing, you need to decide the embedding function as did I above. Why? Because when you insert text, when you try to query the ChromaDB, the same embedding function will apply. That's the idea. So let me continue here. So import the client. Here, as you see that I provide another function. So I provide the collection name, embedding function, and then I just create the client. I just initialize the collection by the collection name and the embedding function. So here, as you see that I provide the collection name papers. Let me run it. Papers, and then the create collection for the collection name and embedding function, and then you see that nothing inside in the collection yet because we haven't inserted yet. All right, we move to another important topic before inserting our text to the ChromaDB. The idea is that we need to create some metadata for each chunk or for each document. It is up to your requirement, application requirement or needs, how to decide this. But for my example, I decided 2 metadata. One is the document. So actually this is the document title. The second is the category of the paper. So I decided this category. For example, this is a journal paper, this is a conference paper, like that. And after that, when I provide my text chunks, how many chunks in the tokens, I mean the 128 chunk long tokens, then I provide the file name, then I provide the category, and then I provide the initial ID, because in the relational databases we provide the, for example, the row IDs. Here this in ID performs functions the same, the row ID. Okay. After that you see that here, let me run. So when you run this, actually you would see indeed it works, and we create for the first 5 I am showing here 5 metadata. So we have the IDs, we have the journal name, we have the we have the paper name, paper title, and we have the journal paper as the category. Of course it depends on your requirement, you can change all this according to the requirements. Now I am ready to include all the data, I mean the metadata and the 128 token long text. Therefore I have another function. I have to provide the IDs, I provide the metadata, I provide the text in 128 token size, and I provide the name of the collection that I will insert. So here is the Chroma collection add function to do all this for us. After that, let me run this. You would see that we are adding our first document, and at the beginning the size is, you will see 0, the collection size. There is nothing in the collection. After that 41. Remember that we have the 41 chunks in that document. So basically you can just access it by using the ID of the chunk. So you see that here the ID of the chunk, it arrives the result as the ID, the embedding, the metadata, and in the metadata you see the category and the document title and the document itself. If you provide the URL, and the other data will be here as well. It depends on your requirement analysis. Now we arrived, so far we all deal with the single file. Now we can talk how to do all these things in multiple documents. But before going on, let me check if there are live comments already, any questions or not. Let me check. I have not see any questions. So if you have any questions, please do not hesitate to share. And if you would like to support the channel, please click the like button, and or you can write down a simple comment so I know that you are there. Alright, let's continue. Okay, now we are uploading these files. All right. And then for each file, it converts the pages to text. As you see that now 8 pages, then 14 chunks, then 41 chunks inserted to the collection. Then it moves to the second PDF and it applies the same logic. So now the collection just get extended from 41 to 47 and it moves to the next PDF. In the next PDF it goes like that until all the documents finished. So when all the documents finish, you would see that we have total 95 chunks for the moment. Alright, 95 chunks as you see in the resulting collection here. Okay, now we can check, for example, the 84th document or chunk in our database. It is coming from this PDF and it's a journal paper. The content is like that. So we have successfully insert multiple documents parts into the Chroma database. Alright. Now how can we query this? The query is simple. Let me show you the my function. By using the Chroma collection query method, we provide the query itself and what we are gonna expect in the result, the document itself, metadata as well, and distances. Here is the distances means actually the likelihood of the two things, query versus the document. As you remember that we convert the query into the vector representation, we convert the documents all into the same vector representation. Then by just comparing these two vectors, we would understand the distance of these two documents locations in the hyperdimension of that vector space. And if they are close, we hope that they are related with each other. If they are distant, they most likely not related. But this distance are calculated according to the context, not according to the keywords. Alright. After do this, let me show a query and the context search. Here what are the main differences in active and passive path scheduling you see here. Why I choose this one? Because in the paper I know that the exact wording is route planning can be static or dynamic. Here in my query I use active and passive instead of static dynamic, path instead of route, scheduling instead of planning. So it is not the keyword search, but it is just a context search. We would like to see that if they understand the context. Okay. And then let's run and let's request 10 results from the collection. And then let's get out the results. So in the results, as you see, okay, in the results you see that there are the 10 documents and each document's parts is here, but it's really hard to read all these things for a human being. So what I would do is write another function to just show the retrieved chunks in a better way. So I write this function show results. That function just show me the results in a better representation, so it's much more readable. Let me go. So you can use this function by yourself as well. So document 1, document text, and from which PDF, and what is the distance. So the number is small, it is better. Smaller is better. Okay. So if you look at the content, you would see that route planning, dynamic route planning, route, and so it understood that we are looking for that part. So it's successful, and there are, let me go, 10 pages I requested, 10 chunks. Here in the last chunk, you see that the distance is getting higher. So this chunk most probably is not related to our query. If you go over these, here it is still related to UAVs, routing, scheduling, etc., but it's not directly related. Alright? So this distance metric gives you an idea how much the query and the retrieved document are related. The smaller number is better. So I have other examples. Let me pass these examples. Okay. We can request only showing the results, because in the next upcoming tutorials I will use only the results to the large language model. Before finishing, I would like to share two things which is very beneficial for you. First, if you know some information about your documents, and if you would like to apply the query according to some metadata, you can filter the query results, or you can apply the query on some filtered chunks. How can we do? Basically, you can create for example, in here I will show a document filter. Remember that I have the two metadata, the category and the document, right? So I will create a document filter. So I am saying that just query text in that PDF. So here in the where condition, I provide the metadata information, title, document, and my condition. If this condition is true, the query will be applied only on these chunks. So if you see the results, you would see that all these results are coming from that PDF. So it's very useful if you know the knowledge base very well. So apply this logic. Okay. So here I just change my functions, revise, so that it can work with that query type as well. Alright, let's move on. Sometimes actually when you provide some queries, maybe the result or the answer wouldn't be inside your knowledge base. At that time you see that you can end up with no results found. So you need to take care of this as well. Sometimes some results arrive, but they are maybe totally unrelated to your query. Now let's go over and handle this situation. So assume that you apply some queries and then you got some results, but as we discussed that maybe there is no results return, or some results return but with very high values with distant results. So you would like to filter out these distant results, because most likely they are unrelated, and most likely in the upcoming videos we are gonna see, tutorials we are gonna see, they might distract the large language model. Therefore we need to filter out. So here I just define a threshold, distance threshold. If the results are has less these values, then they will be in the result set. If there are some text which are distant more than this value, then they are gonna filter out. That's the simple idea. So here, if you see that, let me run. So if it's 130 distant value 1.36, you would see that we might now we don't have any results. Let's see. Only one document with 132. Let's make it 40 and run again. We would end up maybe more results. Let's see. Okay. Therefore, you have some node. You can just play with this. In that node, you can put this distance threshold according to your knowledge base, so you can filter out the most likely unrelated chunks from the result set, because we are gonna provide this result set along with the query to the large language model. So if they are all unrelated, the large language model would be distracted. That's the idea. Okay. So I almost finished with that example. So what we have seen, we talk about how to upload single and multiple PDF documents. After that, we go over the process step by step. We just convert all PDF to the pages, then all pages to 1500 character long chunks, then convert it to 128 token size text chunks. After that, we apply this to the embedding layer, and in the embedding layer we just convert this text into a vector representation. Actually, we done this with the ChromaDB, and when you create the ChromaDB client and the collection, you provide the embedding function as a parameter, so that when you try to insert or upload some text or query, the collection knows how to convert this query or the chunk into the vector representation by using the provided vector, the embedding function. That's all. Then we talk about how to query the ChromaDB. Then we talk about how to filter out the results according to the metadata field and according to the distance value. I hope that you find this tutorial beneficial for you. If you have any questions, I would like to answer. Let me check your questions for the moment, if there are any. Okay. Thank you for the broadcast. I would like to thank you for here. Okay, the sound is coming perfect. At the beginning we have the problem. Now I think we fixed it. Thank you. So I would like to see it in the upcoming tutorial. In the upcoming tutorial, we are gonna talk about how to create the Chroma client as a persistent one, so that we can use it in any real life application. Thank you for being here. Please do not forget to support the channel. See you in the next upcoming tutorial. Bye bye.